On December 23, 2024, at 2:20 in the morning Hawaii time, lava punches through the floor of Halemaʻumaʻu crater at the summit of Kilauea. Right now, on Hawaii's Big Island, the ground above that same crater is swelling again, and it has done this exact thing right before its last two eruptions. Kilauea has fountained lava 53 separate times since December 2024. That is more high fountain episodes than any eruption in Kīlauea's recorded history. The previous record was 47 episodes, and it took more than 3 years to set back in the 1980s. This eruption matched it in under a year and a half. The most recent episode ended on August 13, 2026, after 9.6 hours of continuous fountaining. Within 2 days, the ground began rising again. The United States Geological Survey now expects the next one between August 21st and August 27th. This is not a normal volcano. Something significant is happening. Today, we're going to break down exactly what the ground is telling scientists right now, why they believe episode 54 is coming within days, and what that means for the people living closest to it. No guessing, no dramatizing, just the facts, the science, and the real stakes. Before we go further, tell me something in the comments. Have you ever seen Kilauea erupt with your own eyes, standing at the overlook? Or have you watched the live camera feed at 2 in the morning waiting for the ground to open up? Describe what it actually looked like, because the footage never captures the sound or the heat. And if episode 54 begins this week the way the USGS expects it to, Earth Dispatch will be tracking it as it happens, with the measurements and the official notices as they come out. Subscribing is the only way you catch that the day it starts instead of a week later. Here is how this whole thing began. That night in December 2024, there is no siren, no evacuation, and almost no audience. The crater sits deep inside Hawaii Volcanoes National Park, and at 2:20 in the morning, most of the island is asleep. Cameras bolted to the caldera rim record the first minutes instead. Cracks open along the crater floor. Lava spreads outward in wide sheets. Then the ground starts throwing it upward. Episode 1 pushes fountains of molten rock about 518 feet into the dark. That is taller than the Washington Monument, a column of liquid stone standing higher than a 45-story building. And it happens inside a crater wide enough to swallow a small town. What makes this eruption unusual is not the first night. It is the rhythm that follows. Kilauea does not settle into a steady, quiet flow the way it has for most of the last century. Instead, it starts fountaining in bursts. Scientists call each burst a fountaining episode, which means a stretch of time, usually under 12 hours, where lava sprays upward from a vent like water from a fountain instead of just spilling out and creeping downhill. Between episodes, the volcano goes silent, sometimes for a few days, sometimes for weeks, then it does it again. That stop-and-start pattern is the strange part. For most of living memory, Kilauea behaved differently. The Puʻuʻōʻō eruption on the volcano's East Rift Zone began in 1983 and kept feeding lava almost without pause until 2018, which is 35 years of near-constant activity. People built their lives around it. Tour helicopters flew the same route for decades. That eruption was a faucet left running. What is happening at the summit today is closer to a heartbeat, a hard pulse followed by silence followed by another hard pulse. Puʻuʻōʻō also set the record this eruption just broke. In its early years, from 1983 to 1986, Puʻuʻōʻō produced 47 separate high fountaining episodes before it shifted into that long, steady flow. Setting those 47 episodes took roughly 3.5 years of on and off activity. For 4 decades, that stood as the benchmark. Anyone studying Hawaiian volcanoes treated 47 as the outer edge of what this kind of episodic behavior does before it either stops or changes character. Kilauea's current summit eruption matched that number on June 1st, 2026. It needed less than a year and a half to do what took Puʻuʻōʻō 3.5 years, which means it produced high fountains at more than twice the pace of the record holder, and it did not stop there. Episode 48 came, then 49, 50, 51, 52. By the middle of August 2026, the count reached 53. Every episode after the 47th is new territory, a number Kilauea has never reached and any eruption scientists have documented since written records began on this island. The people who live nearest to this have watched the count climb the way the rest of us watch a weather forecast. The village of Volcano sits just outside the park entrance, home to fewer than 800 people, close enough that residents can step outside during an episode and see the glow reflected off the clouds above the caldera. Hilo, the island's largest town with about 48,000 residents, sits farther away on the windward coast, and on clear nights people there have seen the summit light up the sky from nearly 30 miles off. This is not a remote crater in an empty landscape. It is a mountain with neighbors, and those neighbors have been counting episodes for well over a year. But that record did not happen overnight. and it does not explain what one of these episodes actually feels like on the ground. Here is how episode 53, the most recent one, unfolded. At 3:45 in the afternoon, Hawaii time on August 12, 2026, the vents at Halemaʻumaʻu open again. The escalation is fast. Within the first hour, lava clears the vent rim and climbs. The north vent, one of two main openings inside the crater that have fed most of this eruption, becomes the dominant source. It drives a fountain that reaches roughly 500 feet at its peak, about 150 meters, which again is that 45-story building height, except this building is made of liquid rock at temperatures above 2,000 degrees Fahrenheit, and it is rebuilding itself every second. Then it keeps going and going. Episode 53 runs for 9.6 hours, which is longer than a full work shift, from late afternoon on August 12th into the early hours of August 13th. That duration matters because most episodes in the sequence have been shorter. A fountain that sustains itself for nearly 10 straight hours is moving an enormous amount of material, and the numbers show exactly how much. At its most intense, episode 53 pushes out about 300 cubic yards of lava every second, roughly 230 cubic meters per second. To put that at human scale, that is enough molten rock every second to fill a standard backyard swimming pool several times over, or to bury an average American house up to its roofline in under a minute. Not per hour, per second. And it holds near that pace long enough to change the shape of the crater floor. By the time the fountain dies down, episode 53 has delivered roughly 6 million cubic yards of new lava, about 4.6 million cubic meters. That is enough to cover a large city park in a layer several feet deep, or to fill more than 1,000 Olympic swimming pools. Inside the crater, that volume spreads across somewhere between 40 and 50% of the entire Halemaʻumaʻu floor. Half the crater floor resurfaced in one afternoon and evening. Here's what makes this eruption genuinely difficult to predict, though. Episode 53 is not the biggest one. It is not even close to the biggest one. Episode 52, which came before it, also topped out near 500 feet, but it threw an ash and gas plume roughly 19,000 feet into the air. That is higher than most commercial aircraft crews on a short-haul flight, a column of volcanic material punching well into the layer of atmosphere where weather happens, tall enough that pilots and air traffic controllers pay attention to it. And episode 51 went further still. Its fountain peaked at about 950 feet, nearly twice the height of episode 53, which is a column of lava taller than the Eiffel Tower's second observation deck standing free in open air. Same volcano, same vents, same basic mechanism, roughly double the height, just 2 episodes apart. That variation is the heart of the problem for anyone trying to forecast this. The timing of these episodes has become fairly readable, and we will get to exactly how in a moment. The intensity has not. Scientists can say with real confidence that another episode is coming and roughly when. They cannot tell you whether it will be a 500-foot fountain or a 950-foot one, whether it will last 90 minutes or push past 10 hours, or whether it will send a plume high enough to matter for aviation. Each episode draws from the same plumbing, but the pressure, the gas content, and the shape of the vent opening change every single time. For the people watching from the official overlooks inside the park, that unpredictability cuts both ways. Someone standing at the rim during episode 51 saw one of the tallest lava fountains in modern Hawaiian history. Someone standing in the same spot during a shorter, lower episode saw something extraordinary but far less dramatic. Nobody gets to choose which one they get. If that is what one episode looks like, the real question is how scientists know the next one is coming. The answer sits in a notice published by the Hawaiian Volcano Observatory on August 18, 2026, timestamped 1759 UTC. It is short, technical, and, read carefully, it is a warning written in the calmest possible language. It states that immediately after episode 53 ended, the ground at Kilauea's summit switched from deflation back to inflation. It also notes that glow is visible again from the vents inside Halemaʻumaʻu. Those two words, inflation and deflation, are the entire forecasting method. Summit inflation means the ground surface at the top of the volcano is slowly rising, swelling upward as molten rock and gas build pressure in the shallow reservoir underneath. Deflation is the opposite, the ground sinking back down as that pressure escapes during an eruption. Instruments called tiltmeters measure this by fractions of an inch, angles far too small for a person standing there to feel or see. Scientists read that rise and fall the way a mechanic reads a pressure gauge. Pressure climbing means something is loading up. Pressure dropping means it just let go. Right now that gauge is climbing. Not smoothly though, and this is where the record gets interesting. On August 15, 2026, instruments recorded what the USGS calls a deflationary excursion. That is a short, temporary dip in the rising trend, a few hours where the ground sags slightly instead of swelling. It is easy to misread that as the volcano calming down. It is not. The excursion ended, and the inflation resumed and continued climbing in steps. That stepwise pattern, rise, brief dip, rise again, is the fingerprint. It is exactly what the instruments recorded in the days before episode 52 and again in the days before episode 53. Both times the summit inflated in a staircase pattern with small deflationary interruptions, and both times the next fountaining episode followed. The volcano is not doing something new. It is repeating a sequence scientists have now watched more than 50 times. That repetition is why the USGS can publish a window. Based on the current rate of reinflation and the pattern that has held through the last several episodes, the Observatory expects episode 54 to begin between August 21st and August 27th, 2026. That is the direct answer to the question everyone asks first. Not a vague someday, a 7-day span. But the USGS is also explicit about the limit of what it can do, and that honesty is worth understanding. The observatory states plainly that individual deflationary steps are not possible to forecast. In plain terms, they can see the pressure building and they know what pressure level has triggered eruptions before, but they cannot predict the exact small movement that finally tips the system over. It is like watching a dam fill toward the spillway. You can see the water rising, you can measure the rate, and you can say with confidence that it will spill this week. You cannot name the minute. The other clue is simpler and does not require a single instrument. Glow. When incandescent light returns to the vents at night, visible on the park's live cameras, it means molten rock has risen high enough in the conduit to be seen from the surface again. During long pauses between episodes, those vents go dark. When the glow comes back and strengthens, the magma column is close. Right now, the cameras show glow from the vents. There are two main openings that matter inside the crater, and the notices name them by position: the north vent, the south vent, and at times a west vent. Different episodes have been driven by different vents, and the north vent has carried much of the recent activity, including the tall fountain during episode 53. Which vent takes the lead changes the shape of the fountain and where the lava spreads first. That is the science. Now here's who this actually affects, and just as important, who it does not. The single most important fact in this entire story is one that gets lost when people see lava footage. This eruption is fully contained inside Halemaʻumaʻu crater, within the summit caldera of Kilauea, inside Hawaii Volcanoes National Park. It is not threatening homes. It is not threatening roads. It is not advancing toward any community. Every cubic yard of that 6 million cubic yard episode stayed inside the crater walls. Officials have been consistent and clear on that point through all 53 episodes. That does not mean there is no risk. It means the risk travels through the air instead of across the ground. The gas is the real story. During pauses between episodes, Kilauea's summit releases between 1,000 and 5,000 tons of sulfur dioxide per day. For scale, the upper end of that range is comparable to the daily output of a large industrial complex, released continuously from a hole in the ground with no smokestack and no filter. That sulfur dioxide is where the word VOG comes from. VOG is volcanic smog, and it forms when sulfur dioxide gas reacts with sunlight, moisture, and oxygen in the air to create fine droplets and particles that hang in a haze. It looks like heavy smog on a bad day in a big city. It behaves like it too, irritating eyes, throats, and lungs, and hitting hardest for people with asthma, emphysema, heart conditions, young children, and the elderly. The trade winds push it southwest and west from the summit, which means the communities in the Kau district and along the island's leeward side carry the burden, not the visitors standing at the crater rim upwind. The Big Island is home to roughly 210,000 people. This is not an empty volcanic wilderness with a scientific outpost on it. It is a populated island with towns, schools, farms, and hospitals, and the volcano sits in the middle of daily life. Hilo, the largest town, is about 29 miles from the park entrance, roughly a 45-minute drive on Highway 11. People commute past a live eruption zone the way people elsewhere commute past a river. The park itself is one of the most visited places in the state. Hawaii Volcanoes National Park draws more than 1.4 million visitors a year and generates around $571 million in annual economic impact for surrounding communities. That is money supporting hotels in Volcano and Hilo, tour operators, restaurants, and thousands of jobs. When the volcano is active, visitation climbs. When it goes quiet, businesses feel it. Right now, the park remains open and operating. Crater Rim Drive is open. Chain of Craters Road is open. The Nahuku Lava Tube, the famous walk-through tunnel left behind by an ancient flow, is open. Rangers close specific overlooks and trails when gas levels or ground conditions require it, and those closures shift day to day, so checking the park's status page before driving up is the practical move. Here's the part that makes this week genuinely different for travelers. If episode 54 begins between August 21st and August 27th, as the USGS expects, anyone already in the park during that window has a real chance of watching a lava fountain from a paved overlook with a guardrail at night in relative safety. That is a rare alignment. Most people who see a Hawaiian eruption in person see the aftermath. Seeing the fountain itself requires being in the right place during a window that lasts hours. As this week begins, the mountain has already said what it is about to do. The only question left is exactly when. Think about the two halves of this story side by side. On one hand, a volcano that can throw liquid rock 950 feet into the night sky, resurface half a crater floor in a single evening, and vent thousands of tons of gas a day into the atmosphere. Ancient, indifferent, entirely beyond human control. On the other hand, a small network of instruments measuring the ground tilt in fractions of an inch, quietly enough that scientists can now say what week it will happen next. Kilauea has not become tamer. It has not weakened, softened, or grown more cooperative. The 53 episodes are proof of the opposite. What changed is us. Somebody bolted cameras to the caldera rim, buried tiltmeters in the rock, and wrote down every number for decades until the pattern stopped looking like chaos and started looking like a rhythm. The volcano did not become predictable. It became legible. Now, that is a different thing, and it is worth sitting with, because the fire is exactly as old and exactly as dangerous as it was in 1983. We simply learned to read it. So tell me in the comments, if you had the chance to stand at an official overlook and watch a real lava fountain during the August 21st to 27th window, would you actually go or would you keep your distance? And if you have already been to Hawaii Volcanoes National Park, what did you see when you got there? Subscribe if you want the follow-up, because Earth Dispatch will cover episode 54 the moment the USGS confirms it started, with the fountain heights, the duration, and the measurements as they come in, and send this to anyone with Hawaii travel plans in the next 2 weeks. For them, this timing is not trivia. It is the difference between seeing an empty crater and seeing the ground open up. And there's one more thing worth sitting with before we close, because it changes how you hear the word eruption. We tend to imagine a single event, a mountain that wakes, roars, and goes quiet. What Kīlauea has been doing since December of 2024 is something stranger and honestly more useful to science. It has been keeping time. Episode after episode, the summit inflates as magma pushes up from a shallow reservoir just over a mile beneath Halemaʻumaʻu. The ground tilts. The tiltmeters register it. Pressure builds until the system fails, the vents open, and the fountains climb. Then the pressure drops, the ground deflates, and the countdown restarts. 53 times now. That is not a volcano losing its temper. That is a volcano breathing, which is why the forecasting has gotten so specific. When scientists say the next episode is likely between August 21st and 27th, they are not guessing at a mood. They are reading a pattern that has repeated for 8 months with enough consistency that the intervals themselves have become data. The fountains have reached over 1,000 feet in some episodes. Others have barely cleared the crater rim. The duration has ranged from hours to days, but the rhythm has held, and it will not hold forever. That is the part the researchers keep repeating, and the part that gets lost when a clip goes viral. Episodic eruptions end. Sometimes they transition into something sustained. Sometimes the conduit seals and the whole sequence stops without ceremony. There is no way to know which episode is the last one until the last one has already happened. So every window is provisional. Every forecast comes with the quiet asterisk that the pattern is a courtesy, not a promise. That is the honest version of this story. A volcano that has become predictable enough to plan a trip around, and unpredictable enough that no one will tell you it is guaranteed. Stand at Kīlauea overlook in that window, and you might watch the ground throw fire 600 feet into the Pacific night, or you might watch steam drift off a dark crater floor and go get coffee. Either way, you were there for the 54th breath of the most closely watched volcano on the planet. That is not nothing.